This is Chapter 18, Gastrointestinal and Urologic Emergencies. So, when we're talking about abdominal pain, it's a super common complaint, and oftentimes it's kind of difficult to determine just because you have so much stuff going on in your abdomen. As an EMT, even as a paramedic, we don't really need to know the exact cause of the abdominal pain. What we should be able to do is recognize if that complaint can be tied back to something that could be life-threatening or something that, really we're not overly worried about. The patient, though, is probably in pain. They're probably pretty anxious. So a lot of what we're going to do is a good solid assessment to make sure that we know what's going on, and then probably end up providing a lot of emotional support rather than doing a whole lot of treatments. Really, what we can do for these patients is get them to the hospital where they can have more tools to diagnose and then definitively treat the patient. The abdominal cavity itself has so much. You've got solid organs that make up the gastrointestinal system, the genital system, the urinary system, and then you have a bunch of solid organs like the liver, spleen, pancreas, kidneys, the ovaries in women that bleed. Solid organs bleed a lot. Hollow organs such as your gallbladder, your stomach, the contents will leak out of there and contaminate the abdominal cavity and cause all sorts of issues, but they don't profusely bleed like those solid organs do. So here's the difference in the two. You can kind of see your solid organs are a lot more susceptible to lacerations, also a fancy term for cuts. Your hollow organs are more susceptible to rupture because they often have air in them, and if that gets compressed, then it pops like a balloon, essentially. You can just think of it that way. GI system is responsible for breaking down food and then digesting it. It starts at the mouth. You actually have some enzymes in your saliva that help break down food, and then everything goes down to your stomach. Your stomach does a lot of churning, mechanical type breakdown, but your stomach doesn't actually do any digestion. It's literally just pouring acid on what you've got and kind of churning it around. Your stomach actually churns things back and forth with movement in order to make sure that all the food that you eat is well covered in acid, your stomach acid, so that you can actually break it down. Your liver is pretty assistive in digestion as well. It secretes a substance called bile, which aids in the digestion of fats. Also filters toxic substances produced by digestion itself, creates glucose stores. If you eat too much sugar and your body's like, I don't really need this, but I might need it later. Your liver assists in the creation of glycogen, which is lots and lots of strings of glucose, and it ends up storing it. The gallbladder itself, its whole job is just to be a holding container for bile. It's just a storage container for bile. After you get through the stomach, you end up going to the small intestine, which has three main sections. You've got the duodenum. So you've got digestive juices from the pancreas, from the liver, mixing with the food that's coming in. The pancreas itself releases enzymes that break down starches and fats and proteins. Pancreas also releases a substance called amylase. That's responsible for breaking down starches into sugar so your body can actually use it. Your body doesn't use a lot of complex molecules. It has to break them down into simpler ones that you can actually utilize. Bicarbonate is also produced in the pancreas. When it comes out of your stomach, it's highly, highly acidic. And so if that were to continue all the way down your small intestine, it would actually end up destroying a lot of that tissue. And so your pancreas dumps bicarbonate, which is a base. So acids and base come together to form neutral substances. So it actually puts a bunch of bicarbonate into the duodenum to neutralize all of that acid. And then you have insulin that's produced by the pancreas, and this helps regulate the amounts of glucose in the bloodstream. So it actually acts as a key on your cells so that sugar can get from the bloodstream into the cells where it's actually needed. If you don't have insulin, your blood sugar rises because you don't have the key to get that sugar into the cells itself. And your body keeps going, hey, I'm starving here, help me out. You don't have insulin, so you can eat all you want, but your body's still going to continue to act like it doesn't have any sugar. And we'll get into that more during like diabetes, but just kind of getting you prepared for that. Your jejunum is the next portion. This plays the major role in absorption of all of your products. It does a good portion of the work of the small intestine. So the duodenum is kind of that last step in the overall breakdown of food, and then the jejunum is actually the part that brings it in. Your ileum is that last portion of the small intestine. It absorbs some nutrients that didn't get absorbed in the jejunum, and then absorbs bile so that it can be transferred back up to the liver for future use. And then you also get absorption of B12, which is a vitamin that's necessary for making nerve cells and then red blood cells. Everything then passes into your colon, which is your large intestine. It's made out of 3 portions as well, and then has the appendix attached to it. Food that doesn't get broken down to the point of being absorbed goes through this way. You have a movement that is called peristalsis. That's what actually is moving the food through all of your intestines. Here in the colon, the peristalsis slows a little bit because you need to absorb a lot of what is liquid out of that food that's moving through. That's how you form stool or poop, is that you actually absorb a lot of the liquid that's in that so that you get a more solid waste product that you can actually go ahead and get rid of in the body. You have a couple of additional abdominal organs. The one we're really going to look at right now is just the spleen. It's located in the abdomen, but it has 0 digestive function. That's not what it does. It's actually part of the lymphatic system and plays a pretty significant role in relation to red blood cells and the immune system. It filters the blood. It aids in the development of new red blood cells because it actually breaks down the old ones and then recycles the parts. Serves as a reservoir for blood and then also produces antibodies. Your genital system, the abdomen holds a lot of your reproductive organs. The male reproductive system mostly is contained outside of the body, but there still is quite a bit that's inside, and that's ranging from testicles, epididymis, vas deferens, seminal vesicles, prostate gland, and then, of course, the external organ of the penis. Your female reproductive organ is housed within the pelvic and abdominal cavities completely. So you have your ovaries, fallopian tubes, the uterus, the cervix, and then the vagina is that external opening. So truthfully, males and females in the earliest forms of maturation as a fetus, we all basically have the same parts. And then hormones is what makes us grow into either a girl or a boy. So a lot of a girl's parts are synonymous with a guy's parts and vice versa. It's just how they ended up developing and functioning because of the hormones that our body produces, either as a girl or as a boy. The urinary system controls the discharge of certain waste materials that are filtered from the blood. Your kidneys are the solid organs, one on each side of the body, so you end up with two, that end up filtering and taking stuff out of your blood to end up allowing you to pee it out, essentially. So you've got the two kidneys, you've got ureters, and you have two of those as well. Those run from your kidneys down to your bladder. And then you have one urethra that leads from the bladder to the outside body. Your bladder itself is located right behind the pubis symphysis, and that provides a lot of protection for your bladder itself. So here's kind of what you're looking at. You've got two kidneys. One is a little bit higher than the other, which is just fun fact. The two ureters, bladder, and then you actually have the urethra itself. Your urinary system has a couple of different roles. It obviously, you pee out waste that you don't need, but it actually helps regulate acidity within your body and blood pressure as well. Controls the balance of fluid and electrolytes. Because blood flow is super high in your kidneys, since it does a lot of filtration, it's very sensitive to changes in blood pressure. If you start having issues with your blood pressure, your kidneys often set in motion several different cascades to try and increase your blood pressure. For a normal adult, you form anywhere from 1.5 to about 2 liters of urine a day. The abdominal cavity and organs are lined by a material called the peritoneum. You've got the parietal peritoneum. It lines the walls of the actual abdominal cavity itself, and then you have your visceral peritoneum that covers the actual organs, so it's dual layered. Any sort of foreign material that gets into your abdominal cavity can irritate the peritoneum, causing a condition called peritonitis, so literally just swelling of the peritoneum. But the peritoneum, typically what it does is helps kind of arrange your abdominal cavity, because most things in there are not anchored to anything in particular. And so it kind of helps keep things where they're supposed to be within your abdomen. An acute abdomen is what they would call it. And that's not meaning it's good looking. It means sudden onset of abdominal pain. A lot of times you end up with mild abdominal pain that continues to become severe and progressive. And it kind of depends on what's causing it as to what it looks like. So peritonitis, we did mention already, it's inflammation of the peritoneum, and it typically causes a condition called an ileus. Ileus is the paralysis of the muscular contractions, that peristaltic movement that normally propels material through the intestine, which leads you to retain gas and feces, which then causes abdominal distension. The stomach can't push stuff forward in order to get rid of it, so you end up vomiting, because that's the only way things are going to leave your stomach. So peritonitis frequently associated with nausea and vomiting. Peritonitis can also be associated with bodily fluid loss into the abdominal cavity if things start leaking. And then you're going to start having a patient that's presenting with tachycardia and hypotension. You want to make sure that you look for signs of shock. You may have a fever that's present. So just make sure that you're asking some more questions, because there's several different causes that could be inducing the peritonitis. Some common ones: diverticulitis. This is inflammation of the intestine that causes pockets at weak areas, and that can actually get inflamed. Cholecystitis is gallbladder stones or gallbladder inflammation, and then appendicitis, where your appendix actually swells. And we'll go on in the next video.